Let's talk about Chapter 14, Unit Testing and Test-Driven Development. That's what the TDD stands for. This is all about writing resilient code that will stand the test of time, even if changes are made to it in the future. But it's also about a process for you to follow while you're developing your code in the first place. I'm going to talk about the types of testing, the importance of testing, specifically what unit testing looks like with Jest, a Visual Studio Code tool that will help you with your testing, the idea of positive, negative, and edge cases to help you think through how you're going to write your tests and test your code in different ways, test-driven development, the process of actually writing your tests before you code the code that will satisfy them. And then the last thing is a little bit of a bonus topic. I want to talk about randomization and scope. Because that is something that is often employed, and you might have to set up your tests a little differently if they are run in a random order. Let's talk first about types of testing. And you're thinking to yourself, well, of course, I test my code, right? Before you turn it in, you go through and do some manual testing, throw in a few console logs, test it with different values, and that's just part of your process. And your goal is typically just to make sure it works before you submit it. But there are actually a lot of different ways that things have to be tested when you're talking about a really full code base for a large application in a professional setting. So just to give you a bigger picture, I wanted to talk about each of those. End-to-end testing is something that actually checks what is the path like that the user follows on a user interface. So think of a website. You go in and you click something, you expect to be taken to wherever it is that link is supposed to go. And then maybe you fill out a form and you submit the form and you expect it to go through and take you to the next place. That's the happy path. You want to make sure that the user is getting all the way from where they start to where they're supposed to land for different paths throughout your website. End-to-end testing will check for that. I've written a lot of end-to-end tests in my time as a front-end engineer. And it's definitely a lot, it's a big process, but it is very important. Integration testing is actually testing not just your front end, but also all the other systems that are working together. The back end that's providing the data that's coming from a database. You want to make sure that everything is working the way that it's intended to. And unit testing is something that is what we're focusing on. It actually is very granular. You're testing just very small pieces of code that doesn't really depend on how it interacts with a user or how it interacts with some sort of backend system. It's just the code itself, individual functions or objects that are holding data that your application depends on, things like that. That's what we're going to focus on today. So let's talk about some of the limitations of manual testing that might lead us to decide that we want to have automated testing instead. For one thing, your manual testing is not comprehensive. You are very unlikely to catch all of the possible cases of how your code could be used and what type of output you might have for different types of input. It's also very time consuming. Every time you make a change, you have to run through all of that again. And so because of that, it's very difficult to be consistent. You might test a lot of different things one time, but then you go and you make additional changes to your code and you don't necessarily run through all those same checks. So ultimately, it just means your code is not very resilient. You could have someone come along in the future, it might be yourself, it might be somebody else, who makes some changes and then suddenly it breaks something that they didn't realize might be affected. So you really would want your code to be more resilient, and relying on manual testing is not going to be a way to accomplish that. So with tests, instead, you can make sure that the quality of your code is high and be very confident that it's going to perform well over time. So you want to think through different test cases, including this idea of edge cases, things that are unlikely to happen or less likely to happen, but you could anticipate potential errors and you can make changes to your code to prevent those errors. You also can discover problems you had not even thought about in the process of writing these tests. They will expose things. They'll also expose issues later down the road if someone changes code that could potentially break something they're not even working on directly. It will bring those up and say, oh, hey, we have to change the way we just did this to make sure the code runs everywhere and isn't going to break. So with these automated tests, if you are very thorough now, it will prevent inconsistency later. It saves you a ton of time. Even though it takes time to write them up front, it will save much more time later to prevent problems and trying to find those problems and fix them. And they're also a form of documentation. The way that tests are written, and I'm about to show you how you write them in a way that you describe what it is that it's testing. That is a form of documentation. You can go in and read those tests and very quickly see this is what the test is supposed to do. These are the types of outputs I should see for these types of inputs. And it will allow you to get to know the code a lot better, faster, than if you were just going and looking at the code itself. So Jest is the testing tool we're going to use. I'll talk a little bit about the file structure. You'll have a package.json file that should specify Jest as a required dependency. So of course, you have to use npm install to install it. And then the tests that are written should go in a test directory. In older code, you may see spec or specs, but these days we use tests. And every JavaScript file that you plan to test should have a corresponding .test.js file of the same name. That way you know which one goes with which. Then your JavaScript files where you have the code that needs to be tested needs to export that code. And in the test file, you'll need to import it. And you've learned about modules now, so you understand how that works. So if you look here at this diagram, we've got our package.json file, and then we have two JavaScript files, main and utils. So I've created a tests directory, and inside of that, I've got a main.test.js that corresponds to main.js and a utils.test.js that corresponds to utils.js. This is how you want to do it. Just have a one-to-one relationship between these files. So to start to get into a little bit of the syntax of this, to understand how the tests are written and grouped, we'll talk first about the describe block. So in your test suite, you can organize your groups of tests, your specifications, inside what's known as a describe block. You should have a single describe block for every single thing that you're testing that is unique. So if you have 3 functions, you should have 3 describe blocks, one for each function. Maybe you have a data structure or a class that you're testing. You should have different describe blocks for each one. Describe is a higher order function. It has 2 parameters, so it takes a string and an anonymous function as its arguments. The string should be where you describe what that thing is that you're testing. So all it needs to say is the name of the function or the name of the variable if it's storing some sort of data or a constant or something. And then you'll have additional ways to describe past that when you get inside here. But for now, that's all you really need to do is just say what it is that you're testing. So this entire thing is a describe block. Again, 2 different arguments, the string that goes here, and then the anonymous function. So you can see we start this function definition here as the second argument after the comma. And then we open up the curly braces to provide that definition and all the lines of codes that need to be executed when the tests are run. But you see that's closing parentheses here. That's the closing parentheses for this opening parentheses up here. So you might not be accustomed to reading things like this, but it's pretty typical with a higher order function where you have to provide a function as an argument that you're going to have this spread over multiple lines, even though ultimately it's one line of code that's ending with that semicolon. So you'll have to get accustomed to reading this the way that it is. Describe, string, function. That's the format. So let's say I had a function that I wanted to test called addNums or add2nums. I could just describe it here and say the add2nums function, and then provide an anonymous function to hold the code that's going to test that function. And that's all I need to do just for the describe block. Then inside here, I've got specifications where I'm testing different things about that function. Let's talk about that next. A specification is a test block. So this is something you want to nest inside the describe block. You can have as many as you need to test that particular thing. It is also a higher order function. The structure is very similar to a describe block. It takes a string where you continue to describe what it is you're testing, and then another anonymous function that holds all the code that needs to be executed when that test is run. So here's the thing about the string that you pass into the test block. It should be a continuation of the sentence that you start with describe. So if you say the add to nums function, you should continue your sentence here by saying specifically what it is you're going to be testing. So if this is your entire describe block, you could say the add to nums function, and then in the specification here, continue that and say returns the sum of two numbers. Together it reads as a sentence. The add to nums function returns the sum of two numbers. This is how you want to think about what your text should be in order to make those sentences work, so that no matter what the specification is, it continues off of this and forms a full sentence. And then you're reading that in the console when you're running these tests, and you could tell exactly what it is that's being tested. So once you have this test block set up, where you continue that sentence to describe specifically what's being tested, you have this anonymous function, and all of the data to run the test and the lines of code here are going to be inside the body of that second anonymous function. So let's talk about that. These are called, you would place at least one expectation here in order to compare your actual code against the value that you're expecting. Every time you put an expectation, it's a single test. And you can have multiple tests within one specification or test block, as long as they're all related to that specific aspect that you're testing. You're going to hear people use the term test kind of broadly, and sometimes they might be talking about the whole specification, or they might be talking about just one expectation. It's okay as long as you're clear on what it is you're talking about. But again, just to confirm, the test block is the specification. Any statement that you make where you're comparing values against one another, those expectations, you can have one or more. So what would the syntax be for something like this? Let's look at it. You use expect, which is another function, and you give it your code to evaluate, your actual code. You're going to call a function or refer to some object that is in your code that you have imported. And then you chain on what's called a matcher. That's a method like toEqual. That's probably the most common one. And you give it the value you expect that code to produce so it can compare the two. You can have more than one of these, as I mentioned, and each one of them is going to either return true, which means the test passes, or it returns false, which means the test fails. Your goal is to make sure that the tests always pass. So you want all of these to return true, but they will return false if something is wrong. So let's say that we have the same example we've been working on, right? Over in another file, let's say I have this function add two nums, you pass in n1 and n2, and you return n1 plus n2. We can start testing this entire function by saying, let's describe the add two nums function and start adding some specifications. Our very first one says, let's test that it returns the sum of two numbers. So inside there, we say we expect, and this is test one. And we could say, we need some sort of piece of code to test, right? So that's what we're going to put inside these parentheses for both of these tests. And so for the first one, I could say, let's check that add two nums, if I pass in 2 and 5, I expect it to have a value. And inside each of these parentheses, we might, have those values. So for the first one, I would say, let's say that we expect add two nums with 2 and 5 passed in to equal 7. That's the return value. And then the second test, we could say, let's throw in one more and just test negative numbers. So again, we have the piece of code to test where we say negative 35 and 9, and we expect that to equal negative 26 once the code has been run. This right here is the matcher, this entire thing, toEqual, and then you pass in that expected value. So that's the syntax, and there are actually a lot more matchers besides to equal. So before I do any live coding, I want to talk about those. Some of the others you might see are to be. The thing about to be is that it works only for shallow equality, which means it's only checking at the base level. Like for a primitive, that's fine. If you want to just check if a string is equal to another string, a Boolean, a number, things like that, no problem. But when you talk about objects or functions, the only thing that to be will work for you is if you're checking the identity, like where it's stored in memory. It's not actually going to look inside an array to see if all of the elements are the same, or to look inside an object to see if all of its keys and values are the same. It's only going to look and see, is it the same thing in memory? So to be will only get you so far, unless that's specifically what you are trying to test for. And on the other hand, to equal works for both shallow and deep equality. It will actually look inside an array or look inside an object and compare its contents. So this is a good one to use. And generally speaking, my recommendation is to just always use to equal, because there's no reason not to. The only time that you would is if you were checking identity on purpose. Is something an alias for something else? So here's a couple of examples. We've got two arrays. They have been declared separately, so they really do exist in memory in two separate places. They're not an alias. Array 2 is not an alias of array 1, but they do have the same elements. If I say I expect add nums 2 and 2 to be 4, then no problem, that's true, right? Because I'm just comparing primitives. If I say I expect array 1 to be array 2, it's not the same. That's false, because they exist in two different places in memory. However, if I say expect array 1 to equal array 2, then it actually takes stock of what the contents of those arrays are and checks them, and that will actually resolve to true. So keep that in mind when you're working with objects and arrays, functions, things like that. To be and to equal are going to produce different results for those. There are other matchers that we can talk about. How about to contain? That will actually look inside of an element, it'll look inside an array to look for an element, or it'll look inside a string to check for a substring. So sometimes with arrays, you actually want additional tests too. So here's an example of how we might have multiple expectations for something like an array. Let's just say we're testing the push method. Now, push works. We know it works. It's built into JavaScript. But let's just say we're using it as an example just so we can see how these tests work. We'll test push and say, does push actually add an element to the array? And we'll set up some test data for ourselves and say, let's start with an array that has 3, 2, and 1 as elements. And also, let's just make sure we store what the length is currently, and we'll call that previous length because we're going to change it, right? And then we'll test the code. We'll say nums.push and give it 4 so that it'll put 4 on the end. Now we can say we expect nums to contain the number 4 as an element. And that should return true. We also say that we expect nums.length to equal the previous length plus 1 because we just added something in and changed the length. These would be how you would go about testing a method like this. You have to have some test data, you have to act on that data and actually, run your code, and then you can check some information about it to see if it did in fact change. There's also matchers for checking ranges of values, to be less than, to be greater than, less than or equal, greater than or equal. And to be close to will allow you to accept an approximate value. You can actually use this optional second parameter and say, this is the number of decimal places you can check for. And if it's close enough to this, we'll accept it as being true. To be undefined, to be null, to be not a number. Sometimes you're going to specifically want to check for those things, and you can use these matchers for that. So here's some examples. We expect a tweet, the length of a tweet to be less than or equal to 280. So if we ran that with any sort of valid tweet, we would get true. Let's say we're testing math.py. We expect that to be close to 3.14 when you round to 2 decimal places. That's going to come out true because even though math.py returns a much, more specific number with a lot more decimal places, to be close to allows us to evaluate it based on this. Let's say we take the square root of a negative number that comes back as an imaginary number. We expect JavaScript to evaluate that as not a number. So to be not a number would resolve to true in that case. What if you want to have the opposite? You want to say, you don't necessarily expect something to equal something, you expect it not to equal something. You can use dot not just before your matcher, and it will test the opposite. So in this example, we expect ABC to not equal XYZ. So not to equal, and that means the test passes, it's true. We expect true not to equal false. That's true, so that test passes. And we expect the array with elements 1, 2, and 3 not to contain 4. That's also true, that passes. So anytime it's more convenient for you to just test the opposite of something, not will be a good thing to use. There are a lot more matchers that you could use. You can check out the Jest documentation for that and read about all of those. Okay, I would like to do some live coding now to demonstrate how to write some of these tests. In my unit testing.js file, I have a constant, milliseconds per year, and I've gone through and calculated it by taking the number of milliseconds in a second, seconds in a minute, minutes in an hour, hours in a day, and days in a year, multiplying all of that together, and that should give me, the proper value. So what I'd like to do is write a test that will make sure this value never changes. So if someone comes along and starts messing with this this calculation here, maybe they accidentally break it, right? We want to make sure, we have an application that depends on this. So we're going to make sure that it's not going to ever be a problem. So we can come over to unittesting.test.js in the tests folder here and write our test. However, you'll notice we haven't imported anything here, and we also need to export it down here at the bottom. So I'm going to set module.exports. Ultimately, I'm going to have 3 different things that I export. Milliseconds per year, this constant, this object Bucky, and is alpha only this function. We're going to test all of those. But for now, I've really just got the one that I want to do. So I'll just do this one. And on the test side, I will import it. I'm just going to call this examples. So I'll set a const examples, and that will represent the object that has been exported here from the other file. And then I can use dot notation to access the keys here, millisecond per year being the key. So I'll be able to have access to that value. So we'll write a test for this. The first thing we need to do is have a describe block, right? Describe the millisecond per year constant. That's what we are going to test. So we are just going to describe that. And inside here, after the string, I need to put my anonymous function. And then it'll close out here with the closing parentheses. And then inside the body of this function is where I put my specifications. So let me go ahead and test that it should have a value of 31,557,600,000. And I'll set another anonymous function now so that I can place my expectations inside to be executed whenever this test runs. I'll expect examples.milliseconds per year to equal, and then I'll hard code this number since this is just what I'm looking for. But here, this is the important part. When you write the expect part, you want to make sure that this is your actual code that you're testing. So I'm going to the examples object, that import object, and accessing the value that's been stored under the key milliseconds per year. And as long as my actual code matches this number here, then we'll know that that value is correct and nobody has messed with that calculation and it's still correct. So let's go ahead and run this. I'm going to open up my terminal and say npm test. Notice I have already installed, I've got my no modules folder and my package lot.json. So I've already installed Jest with npm install. So I'm good to go to run npm test here. Okay, and we see one passed. It says the milliseconds per year constant should have a value of et cetera, et cetera. And it took only 2 milliseconds to run that test and pass it. All right. So far, so good, right? All right, let's write some other tests. We have another object here, Bucky, and it has a whole bunch of information in here, right? Full name, James Buchanan Barnes, nickname, the Winter Soldier. So there's a lot of information in here. Some of it may be correct, and some of it actually might not be what we're looking for. So the process of writing our test is going to tell us if we need to fix our code. So let's come over and see what our actual requirements are. The very first thing we need to do, well, actually, the very first thing we need to do is export it. We haven't exported it yet. So let's do that. We'll just export it under the same name. And then we already have the import object here, so we can just refer to it based, from examples, from the examples object. Okay, so now we need to write a describe block. I'm going to describe the Bucky object. That's what we'll be testing. And this time we're going to have several specifications. Okay, I'm going to actually move all of these to-dos up inside here so we can use them with each of the specifications we write. Okay, so we need a test block specifically to test the value of full name and make sure it's correct. So I'll write, I'm going to continue the sentence, right? The Bucky object should have a property called full name with the value of James Buchanan Barnes. And then I'll set up my anonymous function with a place to actually define the expectations that should be executed. And I really just need the one. We're going to expect, and we'll go to our object. So we go to examples.bucky.fullname. And then say to equal James Buchanan Barnes. Okay. So again, just to be clear, examples is our import object. Bucky is the key that points to the Bucky object that's stored in the other file. And full name is the key that is one of the keys of this object, right? This one right here. So we're testing to make sure that this value is what we think it's supposed to be and it hasn't been changed. So let's run it. Okay, 2 tests passed. The Bucky object should have a property called full name with the value of James Buchanan Barnes, and it does. So the test passes, and we know that that data is correct. Let's do another one. We're going to write 2 tests for the value of nickname, but we can write them in the same specification. We're going to make sure that it should be Bucky, and it should not be the Winter Soldier, because he's no longer the Winter Soldier. All right. So write test and should have a property called nickname with the value of Bucky. And then in our anonymous function, we write the expectations. We'll test it both ways. So we'll say we expect examples.bucky.nickname to equal Bucky. And then I can say we expect it, and I'm going to put a not to equal here, the Winter Soldier. So let's run these tests. And we have a failure, right? So if we look at this message that Jest so helpfully gives us, it says, here's the test that failed. The Bucky object should have a property called nickname with the value of Bucky. We expected Bucky and we received the Winter Soldier. And you'll notice here that even though we have 2 expectations, it got stuck as soon as it arrived on one that failed, it got stuck. It didn't even continue to this one. So it's telling us this one was a problem. Now, as it turns out, these go hand in hand. So as soon as we fix this, they're both going to pass. So we don't really even have to worry about this one. But I wanted to show you what it looks like to test it both the positive and the negative way. And we'll talk more about the difference between positive and negative in a little bit. So let's go fix it. Clearly, we have an old value in here and our data needs to be updated for the future. So we're going to fix it and then our test should pass. I'll run them again. Yes, and now everything's passing. The Bucky object has these two tests now and they're both passing. And I say two tests, two specifications. The one with nickname here, this represents both of the expectations that are in that specification. Okay, so we have that now. The next test says we should test that trigger words includes longing, daybreak, and homecoming. And if we look at the original data, we have, trigger words is one of the properties of Bucky that is an array. And so we're going to need to check values in that array. Let's go ahead and do that. We'll say test should have a property called trigger words that includes specific words. I'm not going to be more specific than that in my description here because you need to be a little bit concise here, even though you're trying to be specific. And because I'm going to write multiple expectations, that will take care of documenting what those specific words are. Okay. Now we can write our expectations. We'll have 3 of them. We expect examples dot Bucky dot trigger words. And this is where we're not going to use two equal, right? Because it's an array. We're actually looking for words inside the array. So this is a good opportunity to use to contain longing. Then we can do 2 more of those and just check for the other words, daybreak and homecoming. All right, let's run it. There we go. We have a failure, and that's because it's expecting longing, but when it looked at the array, it sees this longing with a capital L, and we know that strings are case sensitive, so we need to fix that. This is actually a problem with our data. So we're going to come in here and fix it and put a lowercase l. And now when we run it again, everything passes. You'll notice up here, again, it got stuck on the very first one, so it didn't even check daybreak and homecoming yet. But then when we ran it again, all of them passed, so the other 2 weren't a problem. Good, okay. Let's go on to the next one. We're going to test that Bucky's age property is greater than 100. Okay, if we go over and look at this, I actually updated this to make it a function to test something a little different. And so we're testing calculate age. So it's not a property, it's a method, right? I mean, it is a property, but it's a special property, it's a method. So we're actually going to need to run this and call it, and it should return his age because we are subtracting his birth date from today's date. And of course, JavaScript stores everything in milliseconds. So that's why we need to divide by milliseconds per year to get the number of years. So let's test that. We want to test that he is greater than 100. So we'll say it should have a method called calculate age that is returns a value greater than 100. And we're also going to test less than 120. We'll do that as well. Okay. Here we go. That was a long one. So it's kind of wrapping around there, but that's okay. Okay, so 2 expectations then, right? Expect examples Bucky calculate age, and we'll call it with the parentheses there, to be greater than 100. And then we'll do it again and say to be less than 120. All right, let's run these. And it passes. So we have no problem with our calculations here. Now, I want to stop here for a moment and just say that, so far we've been writing our tests and we've been running them and we've just been checking, are they passing, are they failing? However, it is very common in the process of writing these tests that you need to check and make sure your references to your data is correct. And so it's totally normal to come in here and maybe do a temporary console log and just say, hey, what does come back when I try to do that? So we'll go to examples.bucky.calculate age and just run that and see what it says. And when I run the tests, you'll see right up here at the top, console.log 106. So we see the value come back for that. And that can be helpful for you when you're not sure that you're actually testing what you think you're testing. And maybe your test fails and you don't know why. It's always a good idea to throw in a console log and see what that code is actually coming back as, if it's not evident from the code itself, which it most certainly is not when you just have a calculation like this. You can't do that math off the top of your head very easily. So, we're going to go ahead and comment this out because it was really, a temporary thing. And later, if I'm cleaning up my code, I would probably just delete that altogether, but I'll leave it in here just for the sake of the solution so you can see that I did that. Okay. Our last test is to test that Bucky is no longer a Hydra agent. So we're going to write a test, should have a property, is Hydra agent. That is false. Okay. And we expect that examples.bugkey.isHydraAgent should equal false. And we have a failure. So it expected false, but we received true. So this is an example where our test is catching that our data actually needs to be updated because we really are expecting it to be false. And yeah, it still says it's true, so let's change it. He's no longer a Hydra agent, so that definitely is a place where our code is outdated. Now, if I run it again, everything passes. So now we know that everything we needed to check about this has been checked. We have good code coverage there with our testing. All right, the last thing I want to mention here before I move on to some more concepts is that there is a code tool for testing in VS Code. It's called Just Runner. I depend on this heavily because it allows you to selectively run your tests. It's an extension that you can install, and then you can run your test suites like just a describe, you can run the whole describe block. You can run just a single test if you want to. And something to note here is that your terminal must already have been opened in VS Code before these links will be clickable. And then once you've done that, I think once, it's good after that, and it'll actually keep like opening the terminal for you at that point if you're like opening and closing it. Just make sure you've opened it at least once, and then it should make it available. So I'll show you where this is. If you come over here and search for the extensions, you'll find Just Runner. You just install it, and then it's available. So we can come over here to the test file, and you can see these little hot links, right? Run and debug. So let's say, for example, I wanted to run all of the tests for just the Bucky object and skip the milliseconds per year test. I can just hit run right there on that describe block, and you'll notice that it says it skipped this one. So it has 5 tests passing, 1 skipped, 6 total. I could do the opposite, come up here and run just this one. And you'll see it skipped all the ones for the Bucky object and just ran this one. It also has a pretty long and kind of nasty series of commands here that it's running, you would not want to have to come up with that on your own, right? That's what makes Just Runner so great. It makes it super easy for you to just run tests in isolation. So let's say I'm just running the nickname test. I can run just that one, and it runs that and skips everything else. The one thing I will caution you against is make sure when you're adding additional tests, you're still running all of the tests, because if you make changes to your code in one way, it might affect previous tests. And so you still want to make sure everything's passing. So when we do a little bit more coding in a few minutes, I'm going to demonstrate that for you, how sometimes I'm going to run just the one test, but I'm going to go back and run everything within that same block, describe block, to make sure that everything is still passing. Okay, let's talk a little bit about this concept of having positive, negative, and edge cases. You want to think very carefully about the different ways that your code might be used, what types of inputs it might have, and what types of output that might generate in the case of functions. So a positive test case would be something that you're saying, this is what I expect it to be. I'm checking this and I expect this. That's a positive case. A negative case would be, maybe you're handling some situation where the outcome might be something completely different. And so you're testing, I expect this not to be this. And it's typically easier to think about that in terms of checking for return values of true or false, but that really is only going to apply to situations where you have a Boolean result. Otherwise, you might be, checking for values to not be, a certain type of string or this or that. But in general, just going through this thought process of thinking about the different cases is going to help you think about how your code works for a lot of different inputs. Edge cases are the types of things that are unlikely or unusual, something that could maybe break your code if it's not specifically handled. And so you're going to want to adjust your code a little bit to make sure it handles those situations. And when we get to talking about error handling, which will be in the next lecture, that can come into play too. Maybe you have some sort of error that might get tripped and you have to have your code handle it, and you can test to make sure it's been handled properly. We're not going to write tests like that today. We'll deal with that in the future. And it'll definitely be part of your third graded assignment, the Mars rover assignment. Okay, so ultimately your goal is just to try to think through everything from every angle. You might have a simple function that can still fail under certain circumstances, and your code needs to handle that. So here's some examples. Right now, we have an add2nums function that just returns n1 plus n2 when you feed it those two values, right? Let's say we write a test that says it converts strings to numbers and returns the correct sum, and you test it and give it, 2 as a string and 5 as a string, and you say, okay, I'm going to test that equals 7. And then maybe you come along and you say, I'm going to write a test that, it should return not a number if the arguments don't properly convert to nums. So you write a test, I expect this, the word 2 and the word 5, when concatenated, I expect that to still be not a number. I expect add2nums with empty strings to be not a number. But then you run the code and you find out, this test is failing, and this test is failing, and this test is failing. Because, of course, if you were to try to run it just with your code only returning n1 plus n2, here you're going to get these two concatenated as strings and get 25. And here you're going to get 25. And here you'll just get an empty string. So none of these produce the result you actually want. That means you're going to need to modify your code. These are examples of this idea of, edge cases where it's not as straightforward as just making the assumption that everything is going to be a valid number, and that your code will be able to handle it that way. You have to have other circumstances that you can consider. So now let me talk about test-driven development, also known as TDD. This is a process you follow where you write your tests before you write the code that's going to satisfy it. So you make them fail first, and then you write the code that will make it work. And the value of this process really is just that you don't have to go and debug your code after you've written it. It allows you to do a very methodical process of writing the code with very small bits at a time. And then you can be very confident that your code is working the entire time you're developing it. So this process is kind of in three parts. Well, three parts that you then repeat. So red is where you write the test with the expected result, and then you just run it, and you should see it fail. Then you go and you add the code that's going to make the test pass, but only that code. You don't want to write, if you already have in mind, this function should be able to handle like 3 or 4 things. You're not going and writing the code for all of those things. You're doing just what this specific test is requiring. Make that pass. And then if this is not your first time around, you definitely want to make sure all the previous tests pass. And you can also potentially refactor and clean up your code if you have anything that's unnecessary now because you've made changes. Then you just repeat that until you've covered all of the possible cases you can think of. This is TDD. So let's go over and code a new function that is going to allow us to practice this process. We're going to write a function is alpha only that takes in a string and determines if all of the characters in that string are alpha characters only. So we're not going to allow numerical characters or punctuation, that sort of thing. So we're going to test this with some positive cases first, and then we'll get into some negative cases and then some edge cases. But we're going to do it with TDD. We're going to write the test first. I do need to make sure that this is exported so that we can test it. So let's go ahead and say is alpha only and just give it the same name. We'll just use the same name. Something to point out right now is that if this function did not yet exist, when we go to run the test, you're not really going to see it fail properly because it's just going to say it doesn't exist. So you do have to at least have the declaration of it, even if there's no definition just yet, so that it actually can test something that exists. Let me see. So we already have our import with examples. Now we can refer to it as examples.isAlphaOnly. Okay. We also have some test data here that we're going to use. We've got an object that has a bunch of information that provides us with some different types of things we can test, and it's just going to be useful. It's something interesting for us to work with. But what we're testing, of course, is not this object. We're testing is alpha only. That's the focus. But we're just going to use bits and pieces of this to pass into the function to test numbers and strings and spaces and punctuation, all of the things that we want to check for. So first we start with a describe block. So I'll write describe, and we'll say the is alpha only function. And then we'll provide our anonymous function for executing all of the specifications. And we're going to group them all together. So let me put these to-dos up inside there so that we can do them one at a time. There we go. All right, the very first one says, these are the positive cases. Write a test for all alpha using the nickname. And we have a nickname here, so that shouldn't be a problem. We can test that. So we'll write a test and say, and keep in mind, we're testing the is alpha function. So is alpha only function. We want to continue that sentence. So we'll say should return true if alpha only string is passed in. All right, write the anonymous function that will handle our expectations. And we're only going to have one expectation for this one. We'll just say expect. And I'm going to use, I'm going to go and get our function. We can call is alpha only because this is what we need to test. But for our test data to pass in, I'm going to make use of this cap thing here and say cap.nickname. And we'll just pass that in and say, to equal and true. All right. We have a test. Let's run it. Oops, nope, that's not going to work. So I want to run just this entire block here, describe. I'm gonna run this from here, and that way we'll just run the test related to is alpha only and skip all the rest. So already we have a failure, and that's normal because we haven't written the code yet, right? This is test-driven development. We're starting with the test. So it expects true, it gets undefined. And that's just because we don't even have a return statement yet. This is the very first thing we're doing. So let's go over and look at the actual function definition and start with returning something. So we definitely want to return true at the end if we don't find a problem. But before that, we need to check and see, is there an issue? Do we have any characters that are not alpha characters? And if so, we'll do an early return with false. So let's start there. We're going to need something that we can compare against that will let us know if we actually have an allowed character or not. So I'm going to create a variable called isAllowed, or no, just allowed. We'll just call it allowed characters, and put in the alphabet. So GHI. There we go. All right, all of our allowed characters. And then I can take my string and iterate through it. So I'll set up a for loop, go through the length of the string, and look at them one by one. And we're just going to go and look, is that particular character, string at index I, included in this string? Is it a substring of this? And if so, we're good. But what we actually want to check for is it not found, right? So we'll say if not allowed.includes. So if it's not included, and we'll pass in string at index I, then we'll return false. And then we'll just stop. We don't even need to check the rest of the string because we've come across something that's not an alpha character if it's not found in here, right? And that will help us do that. So let's go ahead and test that this works. We'll come over here and run our test again. And it fails. So we're saying, okay, why is it failing, right? Already we realize there's something we didn't think about. And if we take a look at our test data here, we see we passed in cap. We used this as our test value, but it actually has a capital C in it. And this still does not quite work for that, right? So rather than having a longer string that has all of the capital letters in it, what we can do is actually just modify what we're testing and just say, let's make it case insensitive by saying to lowercase. And that way, when it's going to allowed and checking for it, it's checking for a lowercase version of that letter already. And then we don't have to worry about it. Now let's run it again. Okay, so it passes now. So we know that it does, in fact, return true if all of them are included in here, because it checked every single character and checked to make sure that it was included. And therefore, this never triggered because they were all there. So it continues on past the loop and returns true. Good. So that's one positive case. We could also write another positive case here for all alpha with spaces, because we would like to make sure that spaces can be included. So I'm not going to go and edit my code yet. I'm going to follow test-driven development, write the test first, and watch it fail. So I'll test should return true if a string with spaces is passed in. Okay. And we can say that we expect, and full name is a good thing to test here, cap.full name, because it's got Steve Rogers with a space in it. So we'll say expect examples dot is alpha only and pass in cap.full name as our test data to equal true. Okay. So that's a positive case. We're checking for true. Being that this returns true or false. It's a Boolean return value. Okay, so let's run it. And actually, let's see. I'm going to run it from here because I need a different test. So I'll run just this one. And we'll see that it fails. And that's because right now, we don't have a way to handle spaces, right? So if we come over to our code, we can say, that's all right, we can fix that. We're going to say that we have one more allowed character in here, and that's space. No problem. Now let's run it again. And it passes. Now we skipped all the other tests. We don't really want to do that ultimately. So let's come back over to our tests. I'm going to come to the top of the describe block and test everything about this function that I'm working on. This is the code that I'm, shifting. So yes, it passes both of those. So we know we're good. We can move on. Good. Okay. Now let's do a negative case. What happens if you have non-alpha characters like numbers or punctuation? Let's do these in two different specifications. First, let's test if the string has numeric characters. Now, to be clear, we're not testing if it's a number. We're testing if it's a numeric character in the string. Good heavens. There we go. Okay, so before we write an expectation here, we need to look at and see what our test data is going to be. We could definitely use the number that comes back from calculate age, but we also said that we wanted to make sure it was a string. So let's just create a little local variable here called numString, and we'll say, let's go to cap.calculateAge and get that, but then convert it to a string. So I'll wrap that in the string function. And now we have a string representation of that age. And then I can write my expectation and use this as our test data. So we'll expect that examples.isAlphaOnly pass in numString. So if it receives that string of numeric characters, we expect that to equal false. Okay, and this is why we say that this is a negative case, because we are checking for a false value and expecting this entire thing to pass, to be true. Okay. Okay, and we see that it does in fact return false. So we don't actually need to change anything about our code this time. It's already working. And that can be a completely normal part of the process. We should definitely run all of the things in the describe block. Let me just do that too. Yeah, good. So everything's still passing. Our code is really, we've already written it in a way that it's handling the case of numeric characters. And we could expect that that's going to be true for punctuation too, but we should still write a test for it. So I'm going to write another specification here that is testing for that. So I'll say, should return false if the string has punctuation. All right. We'll say expect examples is alpha only. And then what should we pass in for our test data? I would say, let's test one of these catchphrases, right? Like I could do this all day with a period, or language with an exclamation point. So let's do that. We'll say cap.catchphrases at index 0. And really, we could test it with both of them as two different types of punctuation if we want to. So I can do that. And we expect that to equal false. This is our a negative case. So we'll do it again. Let's just do it with both of them while we're at it. Okay, so I will run this test and it passes. Yeah, our code is already handling it. So we don't really need to refactor anything. All right, now let's look at edge cases, things that you may not initially think of, but you want to make sure your code can handle it. What happens if we have an empty string? We certainly don't want to allow that. So we could write a test for that. So we'll say, should return false if it is an empty string. And we'll expect that if we run is alpha only and pass in an empty string, that it's going to equal false. Okay, let's run this test. And that fails. It's receiving true. Let's go take a look at why that might be. We take a look at our code here. We see that if an empty string were to be passed in, then this loop would get skipped altogether because there's no length. It's never going to start executing because there's no length. It's just going to skip directly to return true. So in a case like this, you are just going to want to have an early return specifically for this case. So I'm going to say if string is an empty string, then we need to just return false right off the bat and not even allow this to continue. There's no point in even doing this part if it's an empty string. So let's run this test again. And yes, it passes. We also should run all of the tests in this group because, when you start making these kinds of changes, it could affect other things, but they all are still passing, so we're in good shape. The next edge case would be, what if you have something that's only spaces? This is a common issue when somebody maybe types in some spaces and hits enter. And so technically you have a string with spaces, so it's not empty, right? We're going to want to make sure our test can accommodate this. And right now we're saying spaces are valid characters. So it's going to return true if we test something that only has spaces, and that's not what we want. So we'll write the specification should return false if the string has only spaces. And say we expect examples is alpha only. And we'll just test a single space there. That's all we really need to do to equal false. Okay, let's run this. Okay, it fails as expected because currently we are saying that spaces are allowed and that's all we're checking for. So something we could do here at the very beginning is just make sure that if we trim the string and it becomes an empty string, then it's going to get caught by this. So we just have to trim it. So we're going to just reassign string to string.trim. And that way it'll take off any leading or trailing spaces, which means, of course, that if it only has spaces, it'll become an empty string and it'll trigger false. Let's run it again. It's still failing. Oh, yes. Okay, so this is an issue where it's a type error, and it's an issue because it's not even recognizing the matcher. This is when you have a typo in your test. The test was actually a problem to begin with. So if we come back to the test, we can see here, yes, my closing parentheses here should have been right here. That's an easy mistake to make when you have additional parentheses because you're calling a function. But you want the expect parentheses to end before you put the matcher on. So now when we run it, it passes. Good. Okay, and again, I'm going to come up and I'm going to run all of them to make sure they're all still passing. And they are. Good. All right, last edge case that I want to consider is, what happens if you have different non-string types that could be passed into this function? Is it going to be false the way you expect? So one last test block here should return false if value is not a string type. Okay. And I'm just going to write multiple expectations in one specification in this case, so we can kind of cover our bases. And we have a lot of different test data we can work with here. We have this number that comes back to test a number. We have an array here. We could test an array. We have this entire object we could test. We could test the reference to this just to test a function. So let's do all of those. We'll say expect examples dot is alpha only, and we'll pass in cap dot calculate age and actually get that number back by asking for the return value there and say to equal false. That's a number we're testing. And so let's run that. Run just this one test. Okay. And immediately we get a failure, and it's because it does not know what to do with this trim if it's not a string. And this is why we check for data types, because you might use a string method like this, and then that's going to break your code. So it actually, throws a type error. That's a good thing to be able to catch, right? So let's go and see what we're going to do about this. For one thing, we could actually, we don't need the string to be permanently checked with trim. So we could just move this here and say, let's check it with string.trim here and check that against an empty string, and that's fine. So we can remove that from here. And then we say, okay, but we still have the type issue, right? Because it's still going to do that. Well, something to remember about JavaScript is that when you have a compound Boolean condition, it's going to check it from left to right. So we could actually check the type first and say type of string is string, and say or. And actually what we mean to check is if it's not string, right? Type of string is not string, or if we have established that this is not actually the issue, then it goes on and checks this, and it's not a problem to use the string method because we've already said, yeah, it is a string. Let's just check this last thing because it does it from left to right. So this should work for us. Let's run that again. Yeah, and now it passes. Okay. So we can test some other things. I think that this already is probably going to handle any other type that we could do, but we'll go ahead and write them anyway. And I really could just kind of copy this down. Let's do an array. Let's say we remove calculate age, and we'll test catchphrases. We're just going to check for that array. So this is an array, and we'll do another one and say, let's check just cap this whole object. We'll test that. And then we could go ahead and, oh, this was not supposed to be cap.cap. It's supposed to be just cap. There we go. And then here we could actually reference calculate age without calling it, which is going to say, we're just going to test what if a function was passed in. And then the last one I'll do is null. What happens if we pass in null? So examples.is alpha only and null. And we expect that to equal false. All right, so let's just run it for all of these and make sure that the change we made will handle all of these the way we expect. So I'll run it again. Yeah, and we're good. It's passing. So last thing to do now is to run all of the tests related to is alpha only to make sure they're all passing, and all 7 are passing. So we have done our job. All right. The last thing I want to talk about, this is something that's not in the book, but it's an important thing to understand if you're going to be writing tests out there in the wild at a future job. And that's randomization. Jest does not automatically randomize its tests, but that generally is a good practice. And so you can have it do it, and I'll show you the config file in a second. But the idea here is that you want to make sure every single one of your tests is met on its own merit. That you're not, if you have one test that changes a value of your test data, and then you run another test and you're assuming the tests are going to be run in order, then those tests are not going to be stable. So because Jest does not randomize by default, you can add this Jest config file and just set the value of randomize to true. So I've actually done that here. We can go over and look and see. I created this little config file. All I have to do is put this here, and when Jest sees it, it's going to say, oh, hey, you've got some changes for me. And sure, I can turn on randomization. So that's what I've done, and that's making sure that it's not always running them in the same order. So this will ensure that every single time your tests are run, it might be running them in different orders, and if they always pass, you know they're stable. So you might wonder what's an example of something that would make it unstable. Here's an example. You could have mutable structures like arrays and objects, and you may declare some sort of test data outside of all of your tests that are saying, I want to just use this over and over again, this test data. But if it's mutable and you start making changes to it and the tests run in a different order, suddenly things might quite not work as you expected. So in this example, you can see I've got an array of nums, 5, 6, and 7. And I've scoped it globally so that I can use it multiple times. But then I've written my tests in an order where, for example, I'm testing the push method. I say it adds an element to the array. I push 8 into it and say, I now expect that numbers is going to contain 8 and that its length is going to be 4 and not 3 because, this has a 3 and I added 1. Then I write another test. The shift method removes an element from an array and it's supposed to remove the 1 at the beginning. So I shift it. And I say, now I expect it not to contain 5, which was the very first element. And I expect the length to equal 3 because I made it 4, but then I took 1 away. So now it should be 3 again. Well, if these run in the opposite order, we have a problem, right? Because when it runs this, it might pass on the virtue of containing 5 or not containing 5, but the length won't be 3, it'll be 2 because we never added anything to it. And similarly, we get here and we'll expect the length to equal 4 and it won't because we'll have added 1 in, but it'll be back from 2 to 3. So it's very problematic to do this. So there actually is a way to deal with it. And you, instead of having to, have this data inside each of these describe blocks or inside each specification, it's not very dry. You can actually just give test data once and control that it won't be mutated and then it doesn't matter for randomization. So the way you do this is with a before each block. So you just put this ahead of everything and say, let's make sure nums is in scope. So we'll declare it outside of that, but then we're going to assign a value to it and let this reset the value every single time a test is run. Then it does not matter what order it runs in. And it just takes that anonymous function and then you just tell it what to execute. That's all you have to do. So you see here this example, we start out with this array of 3 elements and we say we push 8, we expect the length to be 4, or we shift 1 out and we expect the length to equal 2. Both of those things are always going to be true because it's going to reset this every single time, and you'll be absolutely certain you're starting with the same thing no matter which order these tests are run in, and that makes your test stable. Okay. So this will definitely always be true. This will definitely always be true. You can count on it. I'm not going to do any live coded examples of this, but I did want to mention it just because it's very likely that that's something you could run into in the future, and I just wanted you to be aware of it. Okay, I have a practice tutorial for a really big one that's preparation for graded assignment 3. I just wanted to put it on your radar now because graded assignment 3 deals with unit testing so heavily, but it also deals with classes, and we haven't done that chapter yet. So, but I just wanted to let you know it's out there. It uses Jasmine and not Just, which are related. And so it's mostly exactly the same. I'm hoping at some point I will have a chance to re-record this and use Just. I just haven't had a chance to do it yet. But in terms of the problem solving aspect and the approach of thinking through how to write your tests, that's the most critical part, and that's 100% the same. So I highly recommend this, and you can, get past get past chapter 18 with classes, and then you could take a stab at this, and it'll be helpful for you.